This lesson is solving linear systems by elimination. Elimination is an algebraic approach to finding the point of intersection of two lines. We are trying to find the point that satisfies both equations, or it's the point that is on both lines. The process of elimination is where we try to eliminate one of the variables in both equations by either adding or subtracting our equations from one another. So if we look at this example here, what we can try to do is we're actually going to try a couple of approaches just so you can understand what this process really is. So if I try to add these two equations, so I'm going to put a little plus here, and we're just going to follow the same methods that we did, way back in elementary school, where we'd add all our columns up. So if I add these up, I have 8 plus 4, which is 12. 5y plus 1y is 6y, and x plus x is 2x. So if you'll notice here, when I added these two equations, one of my variables did not eliminate, or we didn't get rid of one of our variables. So let's try this again by subtracting. So I'm going to rewrite this out. I have x plus 5y equals 8, and I have x plus y equals 4, but this time I am going to subtract. Oh, whoopsie. Let's see if we can, I'll just rewrite this. So, sorry, we have x plus 5y, and I have x plus y equals 4. This is equation 2, and this time we are going to subtract. So, again, 8 minus 4 is 4. 5y minus y is 4y, and it's positive 4y. But x minus x is 0x. So if we look here, we now have eliminated our x's because 0 times x is 0. So if I'm going to continue to solve this, I have 4y equals 4. So dividing both sides by 4. So I have y is equal to 1. So I now know what x is. I'm just going to corner that off. I want to figure out, I now know what y is. I want to figure out what x is. So I'm going to take y equals 1, and I'm going to substitute it back into either equation 1 or equation 2. It doesn't really matter because we'll be checking the other equation afterwards. So I'm going to sub y equals 1 into equation 2. So I have x plus 1 equals 4. So I'm going to now subtract 1 from both sides. So 4 minus 1 is 3. So I now have the point of intersection, or what I believe is the point of intersection, is the coordinate 3, 1. But now what we need to do is we actually need to check. We have to check to see if the point 3, 1 satisfies our equation. And since we used equation 1 in order to solve for x, we are now going to, we used equation 2 to solve for x. We're now going to check in equation 1. So check 3, 1 in 1. So I have 3 plus 5 times 1 equals 8. 3 plus 5 equals 8. and that is 8 equals 8. So my left-hand side equals my right-hand side. Therefore, the solution to the linear system is 3, 1. Okay, so let's look at another example. So if we have equation 1 is x plus y equals 2, and equation 2 is 3x minus y equals 2, and we want to eliminate one of our variables. What you should notice is that, based on the last example, is that it's quite easy to eliminate when we have a variable that in both equations has the same coefficient. So if we look here, my coefficient on the x variable here is a 1, and here it's a 3. So that's a little bit more difficult to eliminate. If we look here, the coefficient on the y is 1. Here, the coefficient on the y is -1. And this is where we have, sometimes we call them the invisible ones, because they're just hidden right here. So we actually have 1x plus 1y equals 2, and we have 3x minus 1y equals 2. So if we want to eliminate a variable in these equations by adding or subtracting, the best thing to do is to choose one where the coefficients are the same. So in this case, we're going to eliminate the y's. Then what we need to do is decide whether we're going to add or subtract. If I added, I have 1 plus minus 1, which is really 1 minus 1, is 0. So the best thing here to do would be to add them. So I'm going to add these two equations. So I have 1x plus 3x is 4x, and 1y minus y is 0y, and I have 2 plus 2, which is 4. So I have 4x equals 4. I'm now going to solve, so I'll divide both sides by 4, and x is equal to 1. So I now know what x is, and I have to then substitute x equals 1 back into one of the two equations to solve for y. So I'm going to choose equation 1, so sub x equals 1 into 1. So I have 1 plus y equals 2. And I'm going to subtract 1 from both sides, so 2 minus 1 is 1. So I have my current solution is the coordinate 1, or the point 1, 1. So since I have found what y is using equation 1, what I need to do is to check my work by substituting back into equation 2. So this is my verify or check. So I'm going to sub 1, 1 into equation 2, because that's the equation I have not yet used in order to solve. So this is my verification check. So I will have 3 times 1 minus, and I have y, so that's minus 1, is equal to 2. So I have 3 minus 1 equals 2. 2 equals 2. So my left-hand side equals my right-hand side. Therefore, the point 1, 1 is the solution to the linear system. So this means that this point here satisfies satisfies the equation, satisfies both equations. It's their common point that is on both lines. All right, so now it's your turn. I would like you to solve the linear system that is written there. So please pause your video, try it on your own, and then play it again once you have finished solving your linear system. All right, so hopefully you did pause and are now just checking to see if your solution matches mine. So if we look here, we have to decide which variable to eliminate for. My coefficients in front of the x's are not the same. I have a 5 and a 3. If we look in front of the y's, I have a 2 and a 2. So though these would, the y variable would be the best to eliminate. And since I have both positive, so if I added 2 plus 2 would give me 4, that wouldn't eliminate, but 2 minus 2 would definitely eliminate, because 2 minus 2 would give me 0. So I'm going to subtract. So if I have minus 11 minus minus 9, that would give me minus 11 plus 9, which is negative 2. And 2 minus 2 is 0. So I have 0y and I have 2x. Therefore I have 2x equals minus 2, which is an equation with a 1 unknown. I will now divide both sides by 2. And I have x equals negative 1. Now what I need to do is substitute x equals negative 1 into one of the two equations to determine what y is. So I'm going to, and it does not matter which one. So I'm going to choose equation 2. So I will have 3 times negative 1 plus 2y equals negative 9. So I will have negative 3 plus 2y equals negative 9. And I'm going to add 3 to both sides, so I have 2y equals minus 9. Plus 3 is minus 6. So I'm going to divide both sides by 2. And I have y, whoopsie. Let's erase this. I have y equals negative 3. So I have the point negative 1, negative 3. And I'm going to substitute that back into equation 1 because I did not use that to find out what either x or y were. So now I want to verify my answer by substituting back into that equation. So this is our check or our verification step. So we have negative 1, negative 3. Oops. Make that neater. Negative 3 into 1. So we have 5 times negative 1 plus 2 times negative 3 equals negative 11. So this is negative 6. It's not negative 6, it is negative 5. Negative 5. 2 times negative 3 is negative 6 equals negative 11. I have negative 11, so minus 5 minus 6 is negative 11 equals negative 11. So my left-hand side equals my right-hand side. So therefore, the solution to the linear system is negative 1, negative 3. And hopefully you got that same answer. If not, go back and check to see where you may have made a mistake. Now sometimes you have situations where neither of the coefficients in front of the variables are the same. So for example, if I had equation 1 is x plus 2y equals 2, and 3x, equation 2, 3x plus 5y equals 4. If we look here, I have a 1 and a 3, and I have a 2, and I have a 5. So this is where we think, okay, well, you know, maybe the best solution is just to rearrange, isolate for one of the variables and use the process of substitution. Well, there is another option when we are looking at using elimination. What we can do is we can take one of our equations, and if we multiply it by a number, we can end up with the same coefficient in front of one of our variables. So for example, if I took equation 1 and I multiplied it by 3, what you'll find is that I end up with 3x plus 6y equals 6. And then my equation 2 is still 3x plus 5y equals 4. What you'll notice now is that my equations have coefficients in front of the variables that are the same. So one of the things you have to be very careful with is that you have to multiply absolutely everything by this number. So I'm multiplying x by 3, 2y by 3, and 2 by 3. Otherwise, you've changed the equation. So don't forget, whatever you do to one side, you have to do to the other. So absolutely everything got multiplied by 3. All right, so now we can decide whether we're going to add or subtract in order to eliminate. Because the 3's are positive, the best thing to do would be to subtract. So I'm going to subtract. So 6 minus 4 is 2. 6 minus 5 is just 1, so I have a y, and 3 minus 3 is 0. So I have y equals 2. Oh, well, that was easy. All right, so we have y equals 2. Now what we're going to do, we know what y is. We have to figure out what x is, so I'm going to sub y equals 2 into 1. So I have x plus 2 times 2 equals 2. Bunch of 2's there. So I have x plus 4 is 2. I'm going to subtract 4 from both sides. So 4 minus 4 is 0. And 2 minus 4 is negative 2. So I now have my point of intersection, what I believe is negative 2, 2. But in order to check that, I have to verify that negative 2, 2 satisfies the second equation, because I haven't used that yet to find any of the information. I've only used equation 1. So I'm going to check negative 2, 2 in equation 2. Alrighty, so we have 3 times negative 2 plus 5 times 2 equals 4. 3 times negative 2 is negative 6. 5 times 2 is 10. So negative 6 plus 10 is 4. So my left-hand side equals my right-hand side. Therefore, the point, therefore, the solution to the linear system is negative 2, 2. Okay, now it's your turn again. So I'm going to give you the equations. Equation 1 is 3x plus 5y equals 12, and equation 2 is 2x minus y, it's a minus, equals negative 5. So I'd like you to pause the video, try it on your own, and then when you're done, or you're stuck perhaps, then you can start the video again. Okay, so again, I hope you've tried. So here we go. If you'll notice, again, we don't have any coefficients variables that have the same coefficient. And so one of our options here, we actually have a couple of options, but the most straightforward option is to take equation 2 and multiply it by 5. So we can get the same y coefficient. So I'm going to multiply this by 5. So what that means is equation 1 stays the same. That's a plus. And equation 2 is 10x minus 5y equals minus 25. So again, if you'll notice, absolutely everything, every single one of the terms in the equation was multiplied by 5. 2 times 5 is 10, negative 1 times 5 is negative 5, and negative 5 times 5 is 25. So now we have to eliminate. So the operation that we're going to do is we're going to add them, because 5 plus minus 5 would give me 0. So 12 plus minus 25 is minus 13. And here I have 0y, and 3 and 10 is 13x. So I have 13x equals minus 13. Solving, I'm going to divide both sides by 13, and I have x equals negative 1. So I now know what x is. To find y, I have to substitute that back into one of my two equations. Doesn't really matter which one. I'm going to choose equation 2. So sub x equals negative 1 into 2. So I have 2 times negative 1 minus y equals minus 5. This is negative 2 minus y is minus 5. I'm going to add 2 to both sides, so I have minus y equals minus 5 plus 2 is minus 3. I'm going to come up here. And so what you'll notice now is that I actually have negative y equals negative 3. I don't have y equals negative 3. And so what I need to do, there is, in fact, again, it's the hidden one, or the invisible one. There's a 1 here. It's negative 1. So I'm going to divide both sides by negative 1. So I'm actually going to write that in, negative 1 and negative 1. So I have y equals 3. So I now know what x and y are. So I have the point negative 1, 3. And since I used equation 2 to find out what y is, I have to check the point negative 1, 3 in equation number 1. So I have 3 times negative 1 plus 5 times 3 equals 12. So this is negative 3 plus 15 equals 12. I have 12 equals 12, and left-hand side equals right-hand side. Therefore, the solution is negative 1, 3. Now, often students say, well, what's the point in doing the check? And I have to say it's very, very important, because just even in this example, I've redone it because when I went through, I actually, on my first attempt at making this part of the video, I'd actually made a mistake where I had made negative 5. I'd made negative 5 12. So I actually had I had looked at the wrong number. So instead, or looked at the wrong equation. So instead of using negative 5, I had used 12. So I had to redo it, and I didn't find that until I did the check. So the check is very, very important step in the process. So that way you can make sure that the calculations you have made are correct, and and then you can, it's just a verification step in your answers. So again, that's very, very important. So now what I want to do is just show how to set up some other examples. I'm not actually going to go through the steps of solving them, but there could be situations where you end up with a question or a linear system that looks like this, where you have equation 1 is 5x plus 2y equals 5, and equation 2 is 2x plus 3y equals 13. So in this situation, what you'll notice is that it's not easy to manipulate one of the equations to make the coefficients the same in both equations. So what we end up having to do is manipulate both equations. So for example, if I wanted the coefficients, x coefficients the same, so x coefficients same, I would have to, I'm going to write these out again. So I have 5x plus 2y equals 5, and equation 2 is 2x plus 3y equals 13. If I wanted my x coefficients the same, I'd actually have to find almost like which number, the lowest number that both 5 and 2 multiply into, and that's 10. So I'd have to multiply equation 1 by 2, and I'd have to multiply equation 2 by 5. And that would give me equation 1 is now 10x plus 4y equals 10, and equation 2 is 10x plus 15y equals 65. So, and now the coefficients in front of my x's are the same, and you could solve this by subtracting and then going through to figure out what the solution to the system is, as you did in the previous examples. Now, what if I wanted the y coefficients? So same y coefficients. So I have equation 1 again is 5x plus 2y equals 5, and equation 2 is 2x plus 3y equals 13. And in order to have our y coefficients the same, I would have to multiply this guy by 3 and this guy by 2, and then we'd end up with 6. So we're multiplying by 3, multiplying by 2. So I have equation 1 now becomes 15x plus 6y equals 15, and equation 2 becomes 4x plus 6y equals 26. And then I could solve by elimination that way. So here we have it's a couple of different options, and to be fair, again, it doesn't matter which one you choose. You will still end up with the same answer, and all you'll need to do is verify by substituting back into the original equations. So there you go. You have a little, well, it's not so little anymore, but there's a tutorial in how to solve by elimination.